Looks good, right? How about we make this game together?
So we're going to start with creating a new Flutter project, and it doesn't matter whatever IDE you decide to use. Some people are more comfortable with Visual Studio Code. Personally, I prefer to use IntelliJ. Just make sure you have this Flutter plugin installed, and we'll click next. So we're going to call this BrickBreakerGame. You can leave all of this checked if you want, or you can just choose whatever operating system you want to use, Android or iOS. And I'll click on create. So yeah, we've created our new Flutter application. To test that this works, we have to run the application in our simulator, and I'll just hit the run button here after selecting the simulator. Next, we need to install the Flame dependency to our project. We can find the documentation on how to install Flame and other Flutter dependencies on the pub.dev website. And if we take a look at this under the installing section, we can see here that we can either run this command or we can copy this code into our pubsec.yaml file. So here in our terminal, I'm going to type flutter pub add flame, hit enter, and this will import our dependencies needed for flame. The next step will be to run the flutter pub get. And the reason for this is because anytime you install any dependency using Flutter, you have to always get the dependencies using this code. And if we click enter, now we are good to go. And we can cross check that this has been installed by opening the pubsec.yaml file and scrolling down to dependencies. We should see Flame installed. We'll create a new .dat file called game. And in here, we are going to create a game class that will extend the Flame game. Please make sure that this package flame/game is imported. Then we'll come to the main.start file and we'll get rid of this default code because we don't need it. We'll replace this with the Flame game widget. And we'll pass in the game class we created. Now we will replace this game factory with our game. So we need to add a const modifier here and make sure that the required packages are imported. Of course, make sure to wrap this with the run app. So okay, run app. Next, we're going to add a background color to our game. And to do that, we'll have to override a method called background color, which is a method of the Flame game class. And we'll replace this with our own color. For this game, I'm going to choose a light blue color. And of course add the const modifier. Now if we stop and run this again, we'll see that we have a nice blue background color. Next, we're going to override the onload, update and render methods. I'll just get rid of the future because it's not necessary. So the next step now is to ensure that the game is loaded up in a landscape form. And to do that, we are going to add this line of code. And we are going to make this an asynchronous function. Adding this async here. And we'll await this. And the next step is to wait for Flame to update its size fields. I'm just going to add that as a comment here. Now we can test this. So we'll have to flip our simulator. To make this game responsive, we'll have to add a grid. And by responsive, I mean it should look good despite the screen resolution. We're going to create a grid. And so what this means is that we are creating a grid that will take 0.1 game units, and we'll create a vector. So this vector is going to store the size of our grid on the x-axis and on the y-axis, and we'll initialize it in the onload method. So we'll say, and here we're going to say size.x times the grid, and here same thing but on the y-axis. And what this means is that we are saying that regardless of the screen size of the phone, the size of the grid is always going to be 10% of the screen size on the x-axis and on the y-axis as well. Next, we'll get rid of this super.onload because it's not needed, and we're going to override a new method called onMount, which is usually called immediately after the onload method. So in here, we're going to instantiate every other variable we need. So now that we have this game class set up, we can now add a brick to the game. So to do that, we'll start by creating a new dat file here called brick. And this brick class is going to extend the flames position component. We'll add a reference to the grid size as we're going to use it for measurement purposes. Now we'll add a constructor and set the brick to have the same size as the grid. Next, we override the render method, which will be used to display the brick as a red rectangle with curved borders. We'll implement the getRect method. So what we've done here is that we are saying we want this getRect method to return a rectangle which will have the size of the brick and curved borders with a curve of 10% of the grid size on the x-axis. And of course, we'll instantiate the paint. So now our render method is using the canvas to draw a rectangle, and the rectangle is this our rect here, and giving it a color of red. So now what's left is to add the brick to the game. So we go to the game class and In order to display any object at all in our game, we will need to have a world component and a camera component. The world component will be added to the game, and every other object needed in our game will be added to the world component, and which will be displayed by the camera. So what we've done here now is to create our camera component, which looks at our world, and we are going to anchor it at the top left. Next, we need to add our camera component and our world to the game. And now we can add an instance of a brick to the world. And we can set the position of the brick. So we want to display the brick at the center of the screen. We'll run the application now. As you can see, the brick is being displayed. However, we need to display multiple bricks aligned in rows and columns, which is very easy to do. We'll start by creating a list of bricks, which will store the bricks that we need, and we are then going to populate that list. Now, to populate this list, we need to create a method called populateBricks, and it's going to take in the number of rows and columns needed as arguments. So we need to loop through the rows and columns and add the bricks to our list. And here we're going to add the brick to our list of bricks. So there's one little issue with this. The bricks we are creating are being positioned at the center of the screen. So for instance, if we should call the populateBricks method with 3 rows and 3 columns, we are going to have 9 bricks. However, all 9 bricks will be positioned at the same position, so we won't even notice that there are up to 9 bricks there. So we need to fix this. To fix this, we'll have to create a reference to the position of the first brick on the x-axis. Then we'll position the other bricks accordingly. So the next step now is to add the list of bricks to our world. And that means we're going to replace this so our bricks can be displayed in the game. And of course, we need to populate the bricks first before adding them to the world. For instance, let's say we want to create just a simple 3x3. And as you can see, we have this. There are some issues with this, especially with the positioning. First of all, the bricks needs to be positioned at the center on the x-axis, and we need to have some margin between each brick. We will fix that now. So what we've done here now is to make sure that there is a margin of 2% of our grid size on the x-axis and 1% of our grid size on the y-axis, so that our bricks will not just look clustered together. Let's test this. And let's just add more bricks to this. So let's change this to be 4 by 8. And we can see now we have our bricks all aligned well as we want. But there's one more tweak we need to do. We need to nicely position this at the center, and which is also a very easy step. So what we've succeeded in doing here is that we've calculated the total width occupied by the bricks, including the margin. Then we've used that to know where to position the first brick so that it will stay at the center here. So let's run this now. And as you can see, our bricks are nicely positioned. Next, we'll add a bar to the game, which will be used to prevent the ball from going out of bounds. And we'll start by creating a new file. And just like the brick class, we are going to create a class for the bar and extend the position component. Now we'll add a constructor to this bar class that will take in the grid size as a parameter. And here now we want to set the size of the bar to be 2 times our grid size on the x-axis and half of our grid size on the y-axis. And now we'll add the render method so that we can display this bar in the game. And similar to what we did for the brick class, we are going to generate this rx method, which is going to be the rectangle that represents the bar and the color of the bar. And just a reminder that you should always remember to import every dependency you need. And now, just like we did for the brick, we need to add this bar to our game world. So we'll navigate to the game class, and here we're going to create a reference to this bar. And we initialize the bar in the onMount method. And this is because onLoad method gets executed before the onMount method by Flame, and our bar class needs to be passed in the grid size, which is set in our onLoad method. So we need to initialize it here when we are sure that we've gotten the actual grid size. Also, we need to set the initial position of the bar to be at the bottom of the screen and centralized on the x-axis. And finally, we are going to add this our bar to the world. Now we are going to run this. And as you can see, there's a bar. positioned at the bottom of the screen and also centralized. Based on our game requirements, we need to be able to control this bar by dragging it around on the x-axis alone. So we'll now go ahead and implement that. We will navigate to the bar class, and to be able to drag these components, we will need to add width, drag callback, so by implementing the drag callback class, we are exposed to a couple of methods. One of them is on drag updates, which we can use to update the position of our bar. So this is going to update the position of this bar as we drag it along the x-axis alone. So now we will run the app, and as you can see, it's getting dragged. Now that our bar is working as expected, the next step will be to display the ball, and we'll go ahead and implement that now. To implement the ball, we are going to create a new class called ball. Similar to the bar and the brick class, it's going to extend the position components. And we need to add a reference to the grid size and the radius of the ball. And just like the bar and brick class, we are going to override the render method of the position components. We need to implement the paint. Now we are going to override our onload method so that we can initialize our radius there. And finally, we are going to add this ball to our world in our game class. We'll start by adding a reference to the ball, and we'll initialize the ball here. Now we're going to set the initial position of the ball to be at the center of the screen, just so that it is visible for now. And finally, we are going to add the ball to our world. And now we are going to run the app. And as you can see, the ball is nicely positioned at the center of the screen. However, we need it to be able to move around, so we'll go ahead and implement that now. So we're going to start by navigating to the ball class, and we'll add a new field called velocity. We'll initialize this velocity in the onload method as well. So for now, let's just make it to move down. To actually make the velocity to take effect, we are going to override the update method, and we'll update the position of the ball here. Now, what we are doing here is to update the position of the ball based off the velocity, and we multiply that by the difference in time. And what that does is that it makes the movement smooth, so it doesn't look like the ball is just jumping around. Now we are going to go ahead and run this. As you can see, the ball moves down along the y-axis. Now we are going to make sure that when the ball hits the bar, it's going to go to the opposite direction on the y-axis, which is upwards. To enable collision for any component, you need to add the with collision callbacks. And this provides us with a method called onCollision. So this method provides a reference to the other component that is being collided with. So here we'll say so basically what we are saying here is that if we collide and the component we collided with is a bar, then we are going to invert the velocity on the y-axis. So with collisions, one more thing we need to add is a hitbox. If not, the collision won't be registered. And because we are going to be detecting collision with the bar component, then we need to also add a hitbox to the bar. In that case, we need to override the onload method. And now we've added the rectangle hitbox, we need one last step to enable collision detection, and that is to go to our game class that extends the flame game and enable collision detection. And we'll do that by adding with has collision detection. Now let's go ahead and run our app. As you can see, once it hits the bar, it goes back or it bounces back upwards. So now we want to make sure that if it hits the brick as well, it should go to the opposite direction on the y-axis. Right now, whenever the ball collides with the bar or the brick, it gets deflected only on the x-axis, so it only moves in a linear line up and down. However, we need to make sure that when there is a collision between the ball and the bar or the brick, there is also a deflection on the x-axis depending on what side of the bar or the brick that the collision happened. So the further away to the right or left side of the brick, the more velocity we add on the x-axis. And if the collision is directly at the center, that also means that there won't be any velocity added to the x-axis. And we'll go ahead now and implement that. So let's go ahead and run this now. When the ball hits the left hand side of the bar, it went back up but towards the left hand side. And we just need to add one more thing to this because it's not yet colliding with the bricks, and that's because we've not yet added our rectangle hitbox to the brick class. So we'll go ahead and do that now. Now we need to make sure that the ball can only go out of bounds through the bottom of the screen. We'll go ahead and implement that now. Now to get the reference of the size of the screen, you need to enable the ball class to reference fields in the game class. Adding this is going to expose a variable called game, and that game is a reference to our BrickBreakerGame class. So we can now do this. So what we are saying here is that if the position of our ball is at the end of the screen, or it's at the beginning of the screen on the x-axis, right? We need to invert the velocity on the x-axis, and if it's at the beginning of the screen on the y-axis, so at the top of the screen, right, we need to invert the velocity so it will bounce back down instead of just going out of the screen. So let's go ahead and run the game now. As you can see, it looks nice. You might notice that there may be a little glitch with the ball, but that's okay now because we are going to remove the bricks from the game anyways. However, if you want to temporarily fix this, we can just add an initial velocity to the x position. So now we want to make sure that whenever the ball collides with the brick, we will remove that brick from the game. So we need to remove it from the world, and we need to remove it from our list of bricks. And to do that, we need to add a reference to the game class. And we'll also need to have the collision callbacks. Now let's run our game. As you can see, the bricks get taken off from our game once we collide with it. That's it for today. In our next video, I'll be showing you how to add game menus such as start game menu and game over menus to your game.